PIR-based wireless communication system for energy saving. Abstract: this research paper is aimed to replace KitKat type switching system to a smart automated system for energy saving, leisure, and for physically disabled people. We have made a complete room fully automated. A PIR, passive infrared, sensor is used to detect the presence of human beings in the room. This sensor works on two modes, i.e. in repetitive and non-repetitive mode. Here we have chosen repetitive mode to make the system more efficient and versatile. Firstly, the sensors are placed in appropriate positions and their signals are captured and further encoded using an encoder, which are ultimately transmitted through a radio transmitter. The data received is of 4-bit that is processed by a microcontroller, Atmega 328P, for decoding purpose. The microcontroller sends signal to relay drivers for controlling various home appliances such as fans, tube lights, etc. Introduction. This research paper is an approach to save electricity. Many countries around the world are continuously working on this area. This research paper, project, provides a way to save the electrical energy which is being wasted because of negligence of humans. This system is going to bring paranormal shift in the mission of providing electricity to all. Statistics shows that 67% of developing world still goes without household electricity, which is one of the basic requirement of day-to-day life. Angel Deborah Cecilin claimed in her paper, which is using a GSM module to receive a text message, the system gets commands via messages and with the help of relay it is controlling home appliances accordingly. 1. Francis Kwabena Oduro presented a paper on June 2018, where he has used Raspberry Pi, system on chip, to obtain same result using web page and cameras for capturing pictures too. Wibowo Harry Sugiharto used database replication method to control things remotely. The system uses the fixed IP and it was accessing appliances of Home 3. Kevin Naik in his paper published on November 2018 used IoT platform and accessed appliances remotely with the help of a web page. 4. V. Ram Kumar presented a paper on voice-operated home automation for senior citizens on Novdis 2018. With the help of a microphone in a handheld device, user can give input and can control devices without actually going to the switchboard. 5. Amruthi Setal developed a system with voice recognition and then sending commands via SMS with the help of GSM module. 6. Mukesh Kumar developed a system for paralyzed people in which they can elevate their bed inclination with the help of voice commands. It worked using voice recognition system along with Arduino and relay circuit. 7. Siri Sila Manohar Etal made email interactive home automation system. 8. Vidyaji Etal developed a brain-controlled home automation system on April 2018. It worked on brain waves captured using electrodes and then signals are filtered followed by amplification are fed to switching circuit. 9. Harshada Rajput Etal made a voice-based home automation system using Raspberry Pi. In her approach, with the help of phone's microphone, voice commands are converted into numeric commands and sent to Raspberry Pi using Wi-Fi communication. 10. Priti Kumar Etal made a research paper on smart home automation. In this Bluetooth module was used for indoor communication and GSM module for outdoor communication. User sends text commands to receiving system and switching was done with the help of relays. 11. ML Sharma Etal presented a research paper on smart home system using IoT. Using Android phone with Arduino and Wi-Fi module, ESP8266, commands were sent to microcontroller with the help of Wi-Fi and relays were controlled by the system. 12. In order to provide electricity to all, which is only possible by saving, we have made a fully automated room so that it can save energy and that energy can be transferred to the electricity deficient places. This automated system senses the presence of human in the room and accordingly it will turn on and off the lights, fans automatically. There will be no manual switches. The system has capability of taking decisions. The smart system will check the presence of any human being for 3 minutes, repeatedly, and when it senses no motion it will turn off everything by itself. It will also be helpful for the physically challenged people as it is difficult for them to turn on and off switches every time. So just by adding some sensors and control circuit we can save a lot of energy for current and future generations. And also we can make life of physically challenged people a bit easier. 2. Need of the project. Today the world is suffering due to inadequate availability of electricity. Around 67% of world is living in darkness. This is going to be a serious issue in coming future. Today we see a lot of energy is being wasted because of our negligence and sometimes because of our busy lifestyle. It has been found only few people are sitting in the room and all lights and fans are on in the room, which leads to wastage of energy. In this paper we have tried to save that energy. Benefits of using proposed system. This system is going to save a lot of energy. It will be very useful for physically challenged people. Difficulty of operating KitKat switches in a dark room can be removed. 3. Technology used. In this work, a pyroelectric type PIR module is used to sense very minute motion. With that passive motion, PIR sensor produces a signal of voltage 3 to 5 V. Signal from each sensor is encoded using HT12E and then it is wirelessly sent through radio frequency transmitter of about 433 MHz. The received data after passing through decoder, HT12D, goes to microcontroller. The input is compared with pre-installed commands. All the possible conditions are pre-saved in the microcontroller. The signal is then decoded and 5V data is sent to the relay drivers, ULN2003, which is connected to 15 different relays to drive the loads. 4. Hardware implementation. PIR sensor. WP_20180203_14_02_36_pro.jpg. These PIR, passive infrared, sensors are very sensitive sensors. It senses passive change in infrared rays coming from human body. Infrared rays can't pass through glass, not even from transparent glass, so if there will be any motion outside the room it is not going to sense it. It has got two potentiometers, one for adjusting sensitivity and other for adjusting delay. Delay indicates, till how much time it is going to give output after it senses no motion. Here delay of 3 minutes is fixed, which can be varied according to the requirement. Here operation of PIR sensor is in repetitive mode so that the output signal will be constant. It checks the motion periodically. After it senses no motion for 3 minutes it will give signal 0. This sensor is very sensitive, as it even senses motion of your eyelids. Maximum range of this sensor is 7 m and its view angle is 1080. For processing of data, an advanced version chip Atmega 328P shown in figure 5 is explicitly used in this work, which is quite versatile, consumes less power and moreover cost is very low. Apart from that, RF, radio frequency, transmitter and receiver, 433 MHz, is implemented to establish communication between the receiver and transmitter wirelessly for the range of 500 feet at maximum. The sensors are installed in different parts of the room and the controlling part is placed at one corner, as we preferred wireless communication to avoid the complexity due to bunch of wires. As the RF module transmits serial data and our requirement is to send 4-bit parallel data, that is why we have incorporated encoder and decoder ICs, HT12E and HT12D respectively, which is depicted in figure 7. An encoder IC, HT12E, which converts 4-bit parallel data into serial data which is transmitted using RF link. A decoder IC, HT12D, which converts received serial data from RF link into original 4-bit parallel data which is fed to Arduino for further processing. For switching purpose we have developed a circuit board which contains 15 relays along with relay driver ICs, ULN2003, which is connected to Atmega as reflected in Fig 7. During winter requirement of fans is negligible, that is why two modes of control are implemented consisting of summer and winter modes, and these modes are controlled by two digital pins of the microcontroller. The advantage of this system is that an extra two-way switch is connected to the microcontroller which takes care of switching from summer to winter and vice versa. The working process of entire system is explained through a flow chart which is available in Figure 8 and Figure 9. 6. Layout of proposed work. For experimental basis this work is confined within a room of size 625 square feet which is divided into 9 cubicles of equal size. The lighting and cooling system are provided with 2 tube lights and 4 fans respectively for the same. One sensor per cubicle has been installed at the position indicated by blue triangles in Fig 11. The layout of the room is given below. 7. Result. According to figure number 11, we have categorized fan A, G1, for cubicle 15 and 18, fan C, G2, for cubicle 13, 14, 16 and 17, fan D, G3, for cubicle 12 and fan F, G4, is for cubicle 10 and 11. Tube light B is meant for cubicles 13, 14, 15, 16, 17 and 18, tube light E is for 10, 11 and 12. So we made 4 groups which are shown above in figure 11. Outputs of all sensors in each group are clubbed. 4-bit binary code for all possible combinations is shown in table 1. These binary codes were transmitted through radio frequency transmitter. The receiver does decoding by comparing received value with pre-saved values. When the match is found, it energizes the respective relays, which turns on the respective light/fan. SPST switch is installed for selection of seasons. In summer mode it will control fans and lights both, and in winter mode only lights will be controlled. Outside interference, presence of human beings, will not affect the working of system, because the boundary is made up of glass material which does not allow infrared rays to penetrate. That is why when a person enters in any of the cubicle the light/fan, with respect to season selected, near to him/her turns on automatically, and if he/she leaves the cubicle for more than 3 minutes the appliances running near to the empty cubicle will be turned off automatically. 7. Conclusion. In this paper, we have presented a power-saving technique through an automated system. The philosophy behind this work is that it is quite distinct from other approaches like messaging, email, remote-controlled, brain-controlled, etc. It reduces significant amount of human effort by implementing various sensors. More importantly, this system can provide ease to physically challenged people and makes their life a bit simple and fascinating.